This is the August 2015 exam. All right, so if you don't have this exam already, go on and just Google Regents chemistry exams and bring up the August 2015 exam. Make sure you have a calculator, make sure you have a reference table, and we're ready to roll. All right. This is my last Instagram Live that I'm going through a practice exam. The next Instagram Live is Tuesday night before the exam, and that night I'm going to be doing a open session. So whatever questions you have, I'm going to be doing that. So let's get rolling here. Which subatomic particles are paired with their charges? All right, before I even look at this, here's my nucleus. I have protons, they're positive, they're in the nucleus. I have neutrons, they're neutral, they're in the nucleus. And I have electrons out here and they're negative. So, electron positive, nope. Electron negative, yes. Neutron neutral, yes. Proton positive, yes. So there's my answer. All right, in the ground state, an atom of which element has 2 valence electrons? First I would look at group 2 because they all have 2 valence electrons, but these aren't group 2 things, so I got to go find it. Cr has 1 valence electron, so it's not that. Cu has 1 valence electron, so it's not that. Ni, there it is. Ni has 2 valence electrons. That's my answer. The atoms in a sample of an element are in excited states. A bright line spectrum is produced when the atoms. Okay, so when you have an atom, here's your nucleus, here's the orbitals. If you have an electron here and it jumps out, when it returns back to ground state, it will release energy, and that will give you the color. So it's when it emits energy. All right, which statement describes a concept included in the wave mechanical model? All right, so the wave mechanical model describes the electrons in the orbitals. Let's see what we got here. Positrons are in shells outside the nucleus. No. Neutrons are in shells. No. Protons are in orbitals. No. Electrons are in orbitals. Yes. All right. All elements on the periodic table are arranged in order of increasing. Okay, this goes by increasing atomic number. So I'm looking for atomic number. It's not on here, but the number of protons is the same thing as the atomic number. So there's my answer. At STP, which one is a noble gas? So noble gases are over here. So there's neon. Neon's a noble gas. At STP, oxygen exists in 2 forms, O2 and O3. They have, okay, so if you've got O2 versus O3, they definitely have different structures. So I'm going to get rid of those right away. And because they have different structures, they're definitely going to have different properties. So that's my answer. Which statement describes a chemical property of sodium? So I want to think about how it reacts. Melting point is physical, the mass is physical, conducting electricity is physical, can combine with chlorine to produce a salt. That's a chemical reaction, so that's my answer. Which term identifies a type of chemical reaction? All right, to distill means to separate 2 liquids based on their boiling point. So that's a physical reaction. Sublimation is to go from a solid to a gas. That's a physical change. Vaporization is going from a liquid to a gas, so that's a physical change. To decompose would be like to take a compound and to break it into its 2 elements. So that's decomposition. That's definitely a chemical reaction. Based on table S, an atom of which element has the weakest attraction? Well, attraction is electronegativity. So, all right, I got to go find these. Polonium is 2.0. Sulfur, 2.6, so it can't be sulfur. Selenium, there it is, 2.6, so it can't be that. And tellurium, Tellurium is a 2.1. So nope, it's going to be polonium that has the weakest because it has the lowest electronegativity. All right, given the balanced reaction, what statement describes what occurs during this reaction? So this is my good old BARF question. Broken, absorbed, released, formed. And here I start with an F2 and I'm breaking it and I'm absorbing energy. So to break, I need to absorb energy. So energy is absorbed as a bond is broken. Which atoms will bond when valence electrons are transferred? Transferred tells me ionic, and ionic tells me that I want a metal plus a nonmetal. These are nonmetals, nonmetals, nonmetals. There we go. Sr is a metal, so I want oxygen with Sr. All right, which one is a mixture? Ooh, look for the AQ. That means it's mixed with water. According to kinetic molecular theory, collisions between gas particles in a sample of an ideal gas. So if I have an ideal gas, I want them to spread out. So I'm thinking about that. So will the kinetic molecular theory tell me that an ideal gas is going to increase the energy content? No. Produce strong attractive forces? No, they have super weak attractive forces. Results in a loss of energy? No. But there is a little bit of transfer of energy. So what that means is when gas molecules collide, there is a little bit of transfer of energy. You can't help it. It happens when collisions occur. So there is a transfer of energy. All right, which one cannot be broken down? If something can't be broken down, it's an element. No, there's an element. So just look for something that's on the periodic table. All right, the temperature of a sample of matter is a measure of. Well, as soon as I see temperature, I'm thinking kinetic energy. So it's not potential energy, it's not nuclear, it's not thermal, it's the average kinetic energy of all my particles. All right, under which conditions of temperature and pressure does a real gas behave like an ideal gas? So if I want it to be ideal, I want it to spread out. So if I think of what conditions, the first one is temperature. Do I want it cold or hot? Cold is bad for a gas. Hot is great for a gas because they will spread out. And then 1 atmosphere versus 8 atmospheres. Well, if I want it to spread out, I better not put pressure on it. So high temperature, low pressure is best for a gas. All right, the ratio of chromium to iron to carbon varies among the different types of stainless steel. Therefore, it is A. Well, it's not going to be a compound because compounds have fixed proportions. It can't be an element because it has chromium, iron, and carbon. Those are 3 different elements themselves. And a substance means that it's pure, like an element or a compound. So it has to be a mixture if it has a varied composition. Which statement explains why increasing the temperature increases the rate of a reaction? So if you increase the temperature, the reacting particles have, well, not less energy, they're definitely going to have more energy, and they're going to collide more frequently. There's my answer. An open flask is half filled with water at 25 degrees. Phase equilibrium. So phase, I want you to picture this is my container, and if I have a liquid in here, I'm going to go back and forth between H2O liquid and H2O gas. And the only way I'm going to get equilibrium is if this is a closed container. So I have to make sure it has a stopper on it. All right, which formula is an unsaturated? Unsaturated means it has a double or a triple bond. So I do not want CnH2n plus 2. So I need to get rid of the ones. Oh, I already see this one. That's a doublet, and a doublet is a double bond. So that's the one I want. This is doublet plus 2, doublet plus 2, doublet plus 2. All right, all isomers of octane. So if you have an isomer, they have the same molecular formula, but they have different structures. And because they have different structures, they're going to have different properties and they're going to have different names. Which formula is a hydrocarbon? That means it can only have H's and C's. That has an I, that has an N, that has an O. There we go. That has just C's and H's. In a redox reaction, the number of electrons lost is equal to. So if you have redox, oxidation is losing electrons, reduction is gaining electrons. They have to be the same number of electrons lost and electrons gained. That's why we have to balance first. At what electrode does oxidation occur? So oxidation always happens at the anode. Doesn't matter if it's voltaic or electrolytic, it's always anox and it's always red cat. All right, based on Arrhenius theory, when potassium hydroxide dissolves in water, the negative ion. So potassium hydroxide is KOH, so you're gonna have OH minuses. So that is a base that is donating OH minus. Compared to distilled water, an aqueous salt solution has. So if you have salt in water, it's going to go like this, boop. It's going to have a higher boiling point and a lower freezing point. So both of those are backwards, so both of those aren't right. It is going to be better at conducting electricity because it's going to have more ions in it. More ions makes it a better conductor. All right, according to one acid-base theory, water can act as a base because, okay, there are two definitions of bases. They either donate OH minus or they accept H plus. And when they're looking for the alternate definition, they're always looking for the accept H plus. There's no H minuses. There's no H minuses in our acid-base discussion. All right, compared to the half-life and decay mode of SR90, 226Ra has. All right, so I got to go to table N and I got to look these up. All right, so 226Ra has compared to SR90. Here's 226. Oh, here's SR90. So 226 is 1,599 years. And SR90 is 29 years. So it definitely has a longer half-life. And then 226Ra does alpha, and this does beta. So it's a longer half-life, and it's a different decay mode. Which net change occurs in a fusion reaction? So fusion means you are combining light nuclei, and when you do that, you release a ton of energy. So it has nothing to do with ionic. So I want to cross off ionic right away. And then energy converted to mass? No, we want mass converted to energy. We want to make a lot. So choice 4 is our best answer then. It makes a lot of energy. All right, we're moving on to the